Hello everyone, this is Anil Reddy, Assistant Professor of Mathematics, MLR Institute of Technology, Hyderabad. In this session, I am going to explain about root of f of x is equal to 0 using bisection method in numerical techniques. The overview of the topic is algebraic and transcendental functions, root of equation, how to find root using different methods. Here we have bisection method, Regla-Falsi method, iterative method and Newton-Raphson method. So, in this lecture I am going to explain about bisection method. So, first of all we have to discuss algebraic transcendental functions. The solution or root of the f of x is equal to 0. So, this means our target is to find x, the value of x for which this f of x is equal to 0. For example, x square minus 3x plus 2 is equal to 0. This is my equation. If I substitute x is equal to 1, this answer will be 0. If I substitute x is equal to 2, also the answer will be 0. These are called root of the equation x square minus 3x plus 2 is equal to 0. And this function f of x may be algebraic or transcendental functions. Algebraic, an equation of the form y is equal to f of x. So, this means the function y is equal to f of x can be expressed in terms of polynomial. For example, x cube minus 3x square plus 2x plus 5 or x power 4 plus 3x square x cube minus 2x square plus 5 by 4. So, these are algebraic equations. And transcendental function, a non-algebraic equation is called transcendental equation, that is the function involving trigonometric, logarithmic, exponential, etc. So, for example, x log x base 10 is equal to 1.2 or sin x is equal to x into e power x or log x minus tan x is equal to 7. So, these are all transcendental functions. Next, root of the equation f of x is equal to 0. So, the geometrically the value of x where the graph y is equal to f of x cuts the x axis. So, I can explain this geometrically. So, this is my x axis and this is my y axis. The curve y is equal to f of x which cuts the x axis at some point. So, this is root of the equation f of x. How to find root of an equation f of x is equal to 0? There are two ways. One is direct method and other one is indirect method or iterative method. The direct method, this is an algebraic equation like quadratic equation. For example, x square minus 3x plus 1 is equal to 0. So, this equation is in indiscriminate form. So, we can apply x is equal to minus b plus or minus root of b square minus 4ac by 2a. So, minus 3 plus or minus, here already minus is there. So, 3 plus or minus root of b square, that is 9 minus 4 into 1 4 divided by 2. So, this is 3 plus or minus root 5 divided by 2. This is the exact solution. This is exact solution for the direct method. So, by using direct method we can get the exact solution, whereas indirect method or iterative method, we get approximate solution or approximate root. So, approximate solution means, so we have some error like we have some root 10 power minus 7 accuracy, 10 power minus 5, 10 power minus 2, up to some desired accuracy, and this process starts with some initial guess and improve it by successive iteration. So, if this process of iteration stops when the desired accuracy root is met or reached. Principle of intermediate value theorem. So, all the indirect methods depends on bisection method, regular falsy method, iteration method and Newton-Raphson method. All these indirect methods depends on principle of intermediate value theorem. Here f of x is continuous function on closed interval a comma b. So, the function value, end point of the functional value, that is f of a into f of b, must be less than 0. So, there exist two cases. One is if f of a less than 0, comma f of b greater than 0. The other case is if f of a greater than 0, comma f of b less than 0. So, in the first case, f of a is negative and f of b is positive. So, I can explain this graphically. So, this is my x axis and this is y axis, and this is my a and this is my b. Now, f of a is negative, so I can take as negative side, and f of b is positive, I can take this positive side. Now, this my graph is looks like this. So, this is f of a less than 0 and f of b greater than 0, and the root is this one. This is my root of the equation. Similarly, I can explain f of a is greater than 0. So, that means, so this is x axis and y axis. So, f of a, this is my a and this is my b. F of a is less than, f of a is positive value. So, I can take here, and f of b is negative. So, here, so this is my f of a and this is my f of b. So, my graph is, this graph is looks like here. Okay, so the root is this one. Root of the equation is this point, and there exists at least one root. There exists at least one root, which means, so there exists at least one, or there exists infinitely many roots, but all of them must be odd number. So, that is, so there exists at least one, but not 2, because 2 is even. So, I can explain this graphically. So, this is my positive, this is a and this is b. So, this is my positive and this is my negative. So, the graph is looks like here, this and this, this and this and this. So, how many solutions are there? 1, 2, 3, 4, 5. So, 5 is odd number of solutions. So, is it possible for even number? We can check it. So, this is the positive side and this is negative side. So, I am starting here. So, this, suppose if I stop here. So, how many roots? 2 roots, but it must be reached to here. So, this is not possible. So, how many roots? 3 roots. So, 3 is odd. So, that means there exists at least one real root or odd number of roots such that f of x naught is equal to 0. So, this is the principle of intermediate value theorem. So, bisection method depends on principle of intermediate value theorem. So, finding root of an equation using bisection method. This method is also called as Bolzano method or interval halving method. So, this method is used for finding approximate solution or approximate root because it is indirect method. So, f of x is continuous and it satisfies the intermediate value property. So, I am writing IVT. I am assuming that f of a is less than 0 and f of b greater greater than 0. Bisection method approximate the real root by taking midpoint of the interval. So, I can explain this using graphically. So, this is my x axis and this is my y axis. So, I am taking A here and this is A and this is my B, okay, right. So, f of A is less than 0, so negative side, and f of B is greater than 0, positive side. So, the graph is looks like this. So, this is f of A and this is f of B. So, now we bisect the interval. So, that is A plus B by 2. So, this is the actual root, this is the actual root. So, now we are bisecting the interval, that is A plus B by 2, A plus B by 2. So, let us represent this with x naught. Okay. So, if my x naught is positive, then the root lies between A and x naught. So, root lies between A and x naught. So, I am dividing this interval A plus x naught by 2 and this is say x1. So, this is my x1. If x1 is negative, then the root lies between x1 and x naught. So, I divide again interval x naught plus x1 by 2, this is x2. So, this is my new x2, new root x2. So, we continue this process until to get a closer root of these two solutions. Next example of bisection method. So, find the positive root of x cube minus x minus 1 is equal to 0 using bisection method. So, let f of x is equal to x cube minus x minus 1 is equal to 0. Here interval is not given. So, we have to choose the values. So, let x is equal to 1. So, this is f of 1, the functional value of 1 is equal to 1 cube minus 1 is equal to minus 1, this is less than 0. If I take x is equal to 2, that is f of 2 is equal to 2 cube minus 2 minus 1. So, this is 8 minus 3, 5 greater than 0. Therefore, the root lies between, what is the intermediate value theorem is saying? F of A and f of B less than 0. That means, one is positive, the other one is negative. So, the functional value of f of 1 is less than 0 and f of 2 is greater than 0. Therefore, the root lies between 1 and 2. 1 and 2. So, this is I am taking A and this is B. So, the next approximation root is x naught is equal to A plus B by 2. So, this is 1 plus 2 by 2. So, 3 by 2 1.5. Now, we have to find the functional value of this f of x naught. So, this is equal to f of 1.5. So, this is equal to, so substitute f of 1.5 in the given equation. So, we will get 0.875. So, this is the positive value. Now, we have to choose the opposite signs. So, here f of 1.5 is greater than 0 and f of 1 is less than 0. Now, the root lies between 1 and 1.5. This we can see through the table. So, here n is the number of iterations and a and b are the initial guess values. So, this is I am representing with negative because we got a value as negative if a functional value is negative. So, for our convenience I am taking this minus and this is positive and x is equal to a plus b by 2 taking the midpoint of the interval and this is the functional value f of x. So, here a is equal to 1 and b is equal to 2 taking the midpoint 1 plus 2 by 2 3 by 2. So, its value is 1.5 and substitute this 1.5 in the given function. So, we get 0.875. So, it is greater than 0. So, it is a positive value. Now, replace positive side value, that is 1.5 with this value. So, I am replacing, this is not replacing, this is a writing as it is 1 and this value is replacing because we got a positive value. So, 1.5 is replaced here, and we take the midpoint of these two, 1 and 1.5. So, it is 1.25. Its functional value of 1.25 is minus 0.2968. So, it is less than 0. Now, replace negative side value because we got less than. So, 1.25 is replaced with here, and this is same, we are not replacing 1.5, we are writing as it is. Now, take the midpoint of these two. So, we get 1.375 and substitute this in the given function, we get 0.224. So, it is positive. Now, replace positive side value with this value, and this is same, and again take the midpoint of these two. So, we get 1.3125, substitute this value in the given function. So, we get minus 0.0515, which is less than 0. Now, replace the negative side value with this midpoint value. So, I am replacing with this value, and this is same. So, again take the midpoint of these two. So, we get 1.3437, substitute this value in the function, we get 0.0826, this is greater than 0. Now, replace positive side. So, I am replacing with this, and this is same. So, again take the midpoint of these two, we will get 1.3281, its functional value is 0.01447, it is a positive value. So, replace positive side, and this is same. So, finally, I am taking the midpoint of these two. So, we get 1.32 and its value is negative. Anyhow, so we got up to 2 decimal places same. So, the required root is 1.32. So, in today's session, we have discussed what is algebraic and transcendental functions, what is root, how to find root of an equation using bisection method. In the next session, we will discuss a regular falsy method. Thank you.